Hi everybody who is watching this video. This is Olenjolai who is going to teach you advanced chemistry. Before I go into the lecture 3 of general chemistry, I would like to give you a little bit introduction concerning about this video. First of all, I would like to welcome you into my YouTube channel called the Tanzania Online A-Level Secondary Schools, and then since square bracket is Olenjolai, just like this is my official YouTube channel. Again, I would like to thank you for watching or taking your time on watching this video right now, when I will be sharing critical and even fantastic concepts of advanced chemistry. So, as I said in the previous lectures, that the main focus of these lectures, whether lecture 1, lecture 2, is according to the syllabus of United Republic of Tanzania, and then the main topic, as we say, that the department is advanced chemistry, and then the subject that we are learning is advanced chemistry. The main topic is general chemistry because consisting a lot of subtopics. The subtopic is called the atomic structure according to the syllabus, and then the concept we are still discussing is the mass spectrometer. And I will tell you what the meanings of this number, and then this is lecture 3. It means I've already taught lecture 1, 2, and this is lecture 3. And then we'll be starting with the homework question that I left in lecture 2 at the part of correction. So in this lecture, I will be continuing on solving problems of how to do computation of maybe relative abundance or isotopic mass, or maybe defining some parts of some parts of mass spectrometer, and finding the isotopic masses sometimes, because those are the problems that in different style by using the intensity. And in some of the questions they can ask you that to write the symbols and different issues. So I will be with you, I'll be teaching you, and I will try to share what I know. I don't know everything, but I just know a little about advanced chemistry, and especially for the advanced chemistry. This program is for the senior students. So I don't want to waste much of your time. I would like just to ask you that take all your essential requirements. In case that you want to interact or you want to ask questions about what I have taught you, you have to go to the below of this video. You see the comment sections, then ask your questions as well as you can. I will be happy to see, because I would like to interact with you by using the digital technologies. Okay, so make sure that you ask at least even one question. That I encourage asking questions, because some questions I used to learn myself by asking questions myself, or by asking questions maybe the search engine, or by asking questions different teachers, or by asking questions the chemistry. So I would like also to deliver this concept, and even just to mentor you on asking questions, because we'll understand even complex issues in a logical manner, in such a way that even some of the people, they can get crazy about what you are saying and about what you know concerning about that concept. So make sure also you read the descriptions below the video for more information concerning about this program. So me as a teacher, I have this ruler just for making lines and even for teaching. This is the one of the resources. I have again a piece of chalk. I have again a blackboard. I'm ready. I have also the notes and the questions that maybe I'll be using. So I would like to ask, I have also my scientific calculator for the computations. So even yourself, as a senior students, don't watch this video as an entertainment. This is the educational video, and this is the training video, and it's the most valuable video than ever. So I would like to ask you that take your scientific calculator, take your ruler, take your exercise book, and then take your pencil in case for the drawings, in case that we have, because for today's lecture will be drawn we call the mass spectrum. Okay, so make sure that you have all the resources. Have a rubber beside you, and even now this that make sure that your mind is clear, you are not stressed, you are not confused, and then let us go to the business together and do something great for the rest of your life. Okay, so let us start with corrections of the homework in lecture 2. This is the homework that I offered in lecture 2. and I usual that I might be corrections in the next lecture. So the questions were saying that magnesium had 3 stable isotopes of the masses, 23.985, 24.985, and 25.982 atomic mass unit. The relative abundances of the 3 isotopes are this we have been given. Let's calculate the atomic mass. I know it was a simple question, but let me just help for those who have got who have failed to solve it. So the first step, you can maybe list the data, okay, isotopic masses. You mean that you can, the first step, you can list, or you can say that data given, what we have been given in this question. So we can let M1, let's say for example, isotopic masses to be, let isotopic masses. So we can say let isotopic masses, right? M1 is equal to 23.985, and then this is what it, unit is atomic mass unit. So we used to have dots, and then the second isotopic mass M2 is equal to 24.985 atomic mass unit. Then again, we have M3, the third isotopic mass. So it is what? It is 25, okay, 0.982 atomic mass unit. Okay, the relative abundance of the 3 isotopes is this. So the relative abundance, you can also let the relative abundances, let's say relative abundances, can say P1 is equal to what? Is equal to 39.35, and then P2, this is in terms of percent, right? So percent, even if that's not written, 5.0, this is compositions, 65%. Then we have P3, which is equal to what? Relative abundances of this one, 39. Oh, I'm sorry, this is not in percentage. It's not in percent. These are the intensities. So P3 is equal to 5. Why did I know that is intensities? Because if you sum them, you don't get 100. Okay? So that's the first step. These are the data that will be given. So what are we looking? We are looking for relative atomic mass, or in some of the books we use this notation. So this is what is required. So before we got the second step, it means that we have to recall which formula, or in each case, remember that if you take the percentage at the relative abundance 1 plus this one, you won't get 100. So what does it mean? This means that it's not the relative abundances, this is intensities. So you have to recall the formula for the intensities, right? It's a little bit tricky. That's why I wrote that as a concept. So you have to be careful, because if you divide by 100, you'll be completely wrong. And possibly even most of you have done that mistake. That's why I have to do correction. Okay, so the second step, we say that let us recall the formula. So let us recall the formula of computing what? Of computing relative atomic mass in masses spectrum. So we say that, or I told you in lecture 2, relative atomic mass, this will be given as the summation of the product of what? Intensity times what? Isotopic mass. Say, isotopic masses. So masses. So isotopic masses divided by summation of 40 of intensities. So intensity, so summation of intensity, because it is more than 1. So here the plural word is intensities. Okay? So again, if we use the symbols that we have let the relative atomic mass, for this case, it will be a product of mass 1 times 40, intensity 1 plus mass 2 times 40, intensity 2, or yes, intensity 2, and then mass 3 times 40, intensity. Don't be confused that to let the intensity, because you have already let that. The relative abundance is according to what will be given. So here we have to take intensity 1 plus intensity 2 plus intensity 3. So the relative atomic mass, which you have been asked, or something is called average atomic mass. So for this case, we'll be taking mass 1 times relative abundance 1. So it will be 23.985 multiplied by what? 39.35. Then we plus, we sort 24.985 times percentage to 5.065, right? And then plus what you have, 25.982, then we have to multiply with 5.585, right? 85. And then we divide this with the total abundance, which is 39.35 plus 5.065 plus 5.585. So the relative abundance for that computation, you have to take your scientific calculator, use it effectively, compute the relative abundance in that case. And then what will you get? After finding that, you'll get that, yes. So it means that you'll take 23, let us do together, 0.9885 multiplied by 39.35. And then we plus with open bracket 24.985 times 5.065. And then plus what? 25.982 times what? Times 5.585. And then we divide by 39.35 plus 5.065 plus 5.585. So we get 24.309. That's what even myself that I've got. So this is the response. So let me just put nearby the lens or the camera so you might see. Do you see the response? So even yourself, you have to get the response like this one. So the response, the relative atomic mass, it is 24.039 atomic mass unit. So therefore, when we are being asked that calculate the average atomic mass, so we say that therefore the average, we write like this one, the average atomic mass of what? The average atomic mass of magnesium is 24, and it is true because that's the atomic mass of magnesium. So this is 24.309 and then 4. So if we write the response in 3 decimal places, and so then we find this atomic mass unit. So it is 24.31 atomic mass unit. So this is the final response of what we have been asking. Well, good. So let us go to another question. So let us go to another question. I believe you have understood. In case you have any question, please don't hesitate yourself. Let me just speak a little bit about this telephone number. This is my telephone number. In case you want to offer your thanksgiving to God, in order to support the cost of running, or the running cost and even the initial cost, some of the facilities are still required on this channel. You may send your Thanksgiving by using this number. That's the meaning that why I have put it there. It's not mandatory, but you just like it from your heart. Okay, so again we have the first example. Okay, and then this is the example 4. Again, it has a concept for you to understand and even to pay attention when we be solving. The question states like this one, that copper has 2 naturally occurring isotopes. Copper 63 has atomic mass of 62.92696, right? Atomic mass unit, and an abundance, and that copper 63 has an abundance of 65.15%. What is atomic mass? That's the question now. What is atomic mass of the second isotope? Remember, the concept of mass spectrometer is new. You haven't learned it during the O-level studies. So we are introducing it to you for the first time. Given the average atomic mass of copper, given the average, you know the meanings of average, it means relative atomic mass. The average atomic mass of what? Of copper. So given the relative atomic mass of copper is 63.546 atomic mass unit. So we have to find the mass, or the atomic mass. As I told you, that this concept will teach you how to find a relative atomic mass, and then again will teach you how to find isotopic masses, or intensities, or abundances. Okay, and sometimes when you find the relative atomic mass, some of the questions that maybe an element is hidden, means it's not mentioned. So you have to identify which element is. But for the common elements. So solution. So the first step, as I used to teach you, we say that let us have data given in this question, right? So the question said that copper has 2 naturally occurring isotopes. How many isotopes? 2 isotopes, not 3. So copper 63, this is the first isotope, which have atomic mass of 62.9296. That atomic mass means isotopic mass, atomic mass unit, and an abundance of 65.15%. This is the abundance right now, it's not the intensity. What is atomic mass of the second isotope? Given the average atomic mass of the copper is that one. So we say that isotopic, we have been given isotopic mass, let's say mass 1 of copper is equal to isotopic mass of copper, it is 62.9296 atomic mass unit. Again, so isotopic mass 2 of the second isotope. This is of 40 of copper. This is what required. So you see, today we have been asked what we used to have in the questions, or used to be given in the many previous questions. Then we have intensities, or you have what abundance. The relative abundance of the first, mean that this is P1 or 40 of the first copper, which is copper 63. This one will be given as what? 65.15%. Then we'll be given the relative atomic mass. Relative atomic mass of 40 of copper, the average atomic mass right now, will be given as 63.546 atomic mass unit. So that is all about the first step. So now we are going for the second step. The second step, we say that recall the formula of finding relative atomic mass of 40 of an element. The element there is what? It is copper. So I told you, call what I told you, relative atomic mass. This is equal to the summation for this case, that is case 2. Now we have relative abundance. We'll be repeating these formulas several times. Relative abundance times what? Isotopic mass. The isotopic mass, this is numerator, and then denominator we have summations of abundance, which is equal to 100. So today we are given relative atomic mass. So because there's two isotopes, so the relative atomic mass in terms of the symbols of the two isotopes, there will be isotopic mass 1 times relative abundance 1 plus isotopic mass 2 times relative abundance 2 divided by what? By 100. So this is the formula. So what are we looking for? We are looking the isotopic mass of the second isotopes. So we are not given the M2. All the variables, we are not given the M2, and even the P2 is not given there. We are not given. So it means that in case maybe you want to make the subject, or you want just to simplify and make the M2 the subject, you can make the M2 the subject, okay, as a good chemist. In case you have any questions, please ask in the comment section. Share this video with your classmate. Share it with the pre-Form 5 that you know. Share it with a Form 5 student. Share it with a Form 6 student. Share it with diploma students who are pursuing science. So if you cross multiplication, we have 100 times relative atomic mass. Then we have mass of the first isotopic mass times percentage 1 mass 2 then times relative abundance 2. So you want to make this one the subject, right? So that the third step. So the third step, we say that make M2 the subject, because we are looking for it, not the relative atomic mass, because here we made the relative atomic mass the subject. So the M2 is equal to 100 times relative atomic mass, then minus products of isotopic mass 1 and abundance 1 divided by percentile 2. So 100 is the relative atomic mass, will be given, we know it. The mass 1, the isotopic mass of the first isotope, we know. The relative abundance of the first isotope, we know. What we don't know this one. So that's the fourth step. So the fourth step, we say that let us use P1 to compute it, or to find what P2 of 40 of the second isotopes. Means relative abundance of the second isotope. How do we get it? Remember that here, I would like to tell you that I told you, if you take the first relative abundance plus the second relative abundance, if the atom has only two isotopes, the response is 100. So it means that to get, if you make it, the relative abundance to the subject is equal to 100 minus 1, P1. So then we say that P2 is equal to 100 minus what? 65.15%. So the second relative abundance, if you make subtraction there, 0 minus 5 is 5. Then we have 9. 9 minus 1 is what? It is 8. And then here remains 4. 4 minus, no, here remains 9, right? So 9 cost is, it was 10. 10, yeah, okay, so, wait a moment. So if you do these subtractions, we find that we get to it, because with this one we get 35, we get 34.85%. Because 5 plus 5 is 0 plus 0, then yes, 35, that is 40, that is making 35 or 45? Yes, 35, yeah, okay, 35%. So then now we can compute it. So the fifth step, now we can compute it. We can compute the isotopic mass of the second isotope. How? So isotopic mass of the second isotope is equal to 100 times what? Times 63.2546. Okay? And then we subtract is the product of as 1, which is 62.99296 multiplied by what? By percentage 1, which is 65.15. And then the answer of the numerator will divide with 74.85 at the second percentage. So you just use your scientific calculator, which I believe that you bought purposefully, and the one of the purpose is to perform this, to help you in the kind of the computation like this one. So to simplify, we just find this product, and then we take this product minus this one. You can use any way that to find that multiplications. It's not just a great thing. Okay, so this is 96, 65.15. Okay, and then we take what that is 53, 54.6 minus the response divided by 74.85. So the response is 60. So it means that mass 2 is equal to 64.6 in 2 decimal places, 698. Okay, atomic mass unit. So the questions ask us that the mass of our second isotope. So therefore, you say that the mass of second isotope, is 64.698 in 3 decimal places. So this is the final response. You see, you enjoy? I believe that you're enjoying advanced chemistry and you're enjoying the topic of general chemistry. Stay tuned. Okay, so that is all about the example 4 of mass spectrum. I believe you enjoy, and I believe that you are getting closer to master this concept of mass spectrometer. Okay. So let us go to another question, which is example 5. Okay, so example 5 right now, this is the question which has been asked in this Advanced Chemistry 1 Review Advanced Certificate Secondary Education Examination in 2015, if I'm not mistaken. So it has been asked, this question has been asked in 2015. Okay, so it was 2015. question number, no, 2016. So it has been asked in 2016, year 2016, question number 2C. So let me solve it for you. So this is example 4, example 5, sorry. And this one you have to refer Advanced Certificate Secondary Education Examination, NECTA, of 2015, paper 1. Okay, paper 1. And in case of review, you'll find these questions in 2078. Remember that in case you don't have these textbooks or the questions and answers books, means review books, please go to the descriptions below and then you'll see how you can order them online. You can ship it, I can ship it locally. It means that in the United Republic of Tanzania. So make sure that you follow the instructions that are required there. But watch also the video concerning about the textbook and reference materials. Okay, so this is it was a question to section A, question 2, part C. The questions was testing the concept of mass spectrometry. So it begins like this. We say that the mass spectrum, okay, the mass spectrum of an element enables the relative abundance of each isotope of the element to be determined. Data relating to mass spectrum of an element X whose atomic number is 35. Appear as indicated in table below. Indicated in the table below. Study the data and answer the following questions. If you are joining into this fantastic lecture, I would like to welcome you into this third lecture of General Chemistry in Advanced Chemistry according to the syllabus of United Republic of Tanzania. So stay tuned. Study the data and answer the questions that follows. Mass number of isotopes, mass number of isotope. And then here in another column we have relative abundance. A relative abundance. Okay? So you have two columns, and then we have also three rows. First row, or first, second row, and third row. So here we have 79, and here we be given 81. Here we have 5.5%. Is it 5.5%? 50.5, sorry. This is 50. There's typing error in review. It is 50, not 5%. And then the other one is 49. Because remember that the total percentage or total relative abundance always should be 100. So these are the questions. Define the isotope. You remember the definitions of isotope you learned during your Form 2. What is isotope in atomic structure? Define the term isotope. So define the term isotope. Then number 2, write the conventional convention symbol convention symbols for the two isotopes. For the two isotopes of 40 of element X of element X. Then calculate the relative atomic mass of X to series significant figure. To series significant figures. If you do this, you will get 5 marks. So we have a final exam question which has been asked to A-level students who graduated in 2016. Is it 2015 or 2016? 2016, not 15, in paper 1 of 2016. Remember that general is the content of paper 1 advanced chemistry or advanced chemistry 1. Okay, well, so then let us read the questions quickly and then we solve it. Okay, the mass spectrums of an element enable the relative abundances of each isotopes of the elements to be determined. That the main functions of 40 of mass spectrometer, which give us the mass spectrums as I told you in lecture 1 and 2. Data relating to the mass spectrums of an element X whose atomic number is 35 appears as indicated in the table below. So the atomic number is 35. Atomic number is 35. So because you have written the questions, I would like just to underline some of the keywords. Atomic number is 35. Start the data and answer the questions that follows. So these are the questions. This the data, or this the given table. Define the, we have to draw a good table, actually, that I've been drawing quickly. Define the term isotope, or the meaning of isotope. Write the conventional symbols for the two isotopes of element X. This is the element X, we don't know it. So the names, is this the symbol for the element? So the element, the symbol of elements is not maybe cielo or Na. It means, when I say Na, it means that for sodium OMG, no, it is X. Then calculate the relative atomic mass of X into 7 significant figures, and then so we have 5 marks. Okay, so the questions is very interesting. In some of the reference notes, you may find the same question which have been, the same questions which have been done. So I will solve this question in 2 ways, or under 2 conditions. Let me start with the given condition. So solution. So the solutions, we have defined first the term isotope. So the term isotope is not new in your life of chemistry. So isotopes, this you say that are the elements which have the same, just to remind you, the same atomic number but different atomic mass, different atomic masses are the definitions of the what? Isotope. Okay? Even if that maybe you know the other ones, there's no problems. Okay? So we have to go to Roman 2. Roman 2, I will do it in 2 conditions. Write the conventional symbol for the 2 isotopes. So the way we write symbols according to the chemistry of all levels, especially that may be Form 1, when we have been learning to write Form 1 and Form 2, especially Form 2, we've been learning about the concepts of isotopes, atomic mass, atomic number, in the topic known as the atomic structure of the Form 2. So when you write here, we used to have a number, we call it the atomic number. And then here, as a superscript on left of the element symbol, we used to have atomic mass. So for this now, we say that means that write the conventional symbols. So we say that the symbols of element X are this. So we say that X. So we say that for this case we have, remember that we have been given because they have the same atomic number of 35. So this is 5, set a 5, and this is the first atomic mass, or the atomic mass for the first isotopes, which is 79, and also we have another conventional symbol with atomic mass of 35, and then that atomic number of 35 and atomic mass of 81. So this is the response for that question. So the second condition that I want to challenge, let me challenge you. What if the atomic number you are not given? What if, for example, you be given a question like this one, but the atomic number is not given? How are you going to write? So we say that this is just like a note, is extra. I want to take you some extra mile. We say that if atomic number is not given, then the conventional symbol, because there are some trick questions like that ones, symbols of what? Of element X. Of element X will be like this. This is X, we have our atomic mass, and then 79. Again, we have against our element X, atomic number Z, here it is what? 81. Because the atomic number is not known. Atomic number is not known. Okay? So then we have to go to Roman 3 now. In case you have any question, please ask your questions in the comment section. And also don't be selfish. Share with your friends. Share with your classmate with the Form 5. Classmate from of the Form 5. Share with the Form 6. Share these materials with the pre-Form 5. Okay? So don't be selfish, because even myself, your teacher, I'm no longer, or I'm not selfish. That's why I'm providing this material to you. Which calculate the relative atomic mass of X into three significant figures. So for this one, we say that no need for that, because it's a given starter. So the first step, we have to go into the competitions with computation. So recall the formula of finding relative atomic mass. When we say that the relative atomic mass is equal to what? Is equal to summations of what? Products of abundances. So suppose that is isotopic mass 1 times percent relative abundance 1 plus, because that element X has 2 isotopes, times isotopic mass 2 times what? Times relative abundance 2, not 3, I'm sorry. And then we say that we divide, because it's an average, with the summations of what? The summation of abundances, because it is in percentage, then the sum is 100. So relative atomic mass in terms of mass, atomic mass unit, we say that we have, it is 7. Times 50, 20, 50, and then plus 81 times 49.5 divided by 100. So take your scientific calculator and then do your computation. So you have first 79 times 50.5. Then you have 81 times 49.5, and then divided by 100. So he said that therefore relative atomic mass at atomic mass of what? Of element X is 79.99 atomic mass unit. Atomic mass unit, so there are atomic mass in that one. To select significant figures. So this is how many? This is 4 significant figures. So to select significant figures, we have to estimate this. It has to be 8. This is 8.0. Atomic mass unit. Okay, atomic mass unit. So this is the final response. So meditate on what I have taught you in this lecture up to this moment. Thank you for keep on watching. So let me go to example 6, which is a little bit different in its structure, but is still simple. Example 6. Concept. You're turning around. The diagram below shows the mass spectrum of magnesium. The heights of the three peaks and the mass number of isotopes are shown. Calculate the relative atomic mass. Relative atomic mass of magnesium. So we have our space or our mass spectrum. Intensity, or we call it isotopic percentage. So this is mass number. This is 24. This is 25. Mass number of each isotope. This is 26. Here we have 63. .1, and here you have 9.2. So that's the question which I want to solve before you, as how we solved this previous, but this is a little bit different. Solution. So let us read the question. The diagram below shows the mass spectrums of magnesium, so it is known element. The haze of the three peaks and the mass number isotopes are shown below. Calculate the relative atomic mass of magnesium. So these are the abundances. And if you add these abundances, the sum is not 100. So this is the intensities. And this is the isotopic mass. So you have to get prepared. Solution. First step, let us observe what data given in this question. We've been given a lot of information, but they're in graphic. Atomic mass unit. And then sublet the second mass. Atomic mass unit. Percentage 1 is equal to, but this is intensity, is equal to 63. percent 32 is equal to 8 into 1. Intensity 3. Intensity 3. So those are the ratings. Then we are required to have large atomic mass. Second step, recall the formula. Recall the formula of finding or computing relative atomic mass. So we say that in abbreviation, so in short, relative atomic mass is equal to this is what's required. Because calculate the relative atomic mass of magnesium. So we go for the second step, that day. So relative atomic mass is equal to mass 1 percentile 1 plus 2 percentile 2 so because we have we have this one, the summation is not equal to what? So this is intensity 1. So this is I1. Of what? I1 plus I2 plus I3. And atomic mass is equal to what? Atomic masses 24 times what? Times 63. Then mass 2 is equal to 25. Times 8.1 then 26 6 multiplied by 9.1. Okay? And this one we divide it by what? 63, 8.1, 63 plus 8.1 and then so we say that plus 9.1. What do you find for that computation? So do your mathematical computation by using your scientific calculator on computing this. So simply you have 24 times 63, then 25 times 8.1, okay, so the relative atomic mass of magnesium so the atomic mass of magnesium is 24.28 atomic mass unit. So that the final response for this problem of engineering. Not for engineering, I'm sorry, for advanced. That's all about example 6. Example 7. Example 7, concept. Natural rubidium natural rubidium has average mass mass of 85 So we say the natural rubidium has average mass of 85.467. And is compared of isotopes of rubidium. Compared so rubidium says average mass of this one and is compared with isotope. So with isotope of rubidium, which its atomic mass is equal to 84.9117 atomic mass unit. Rubidium 87. And is compared with isotope rubidium, mass this one, and rubidium and RB 89. Then we have full stop here. Again, let us clean the setting column. The ratio of atoms so we say that in the ratio of atoms of atoms, rubidium isotope or rubidium isotope 85 over 87 in natural. Natural rubidium in natural rubidium in natural rubidium is 2.51. Calculate the mass of second isotope of rubidium. So calculate the mass of rubidium. Calculate the mass of rubidium '87. Okay, try this as your homework. So make sure to try alone that questions. In case you fail, you may ask your neighbor, but not try it for you. Okay, so the question said that natural rubidium has average mass of that ones and is compared with isotope that mass like that ones and rubidium's that one. The ratio of atoms, rubidium 85 over rubidium 87 in natural rubidium is 2.95. Calculate the mass of medium of rubidium. So you just have to calculate the mass of rubidium. So you have to be careful on this concept. Let me leave you another homework. Example 8. For each of the following stage,